Okay, so we were hoping that we would have a new Eiffel edition ready for the summit. We did not, but it is soon ready. So the currently latest edition of Eiffel is the Lyon edition, and the next one will be Arica. So we have, I think, about 4 changes going into the new edition that we're going to talk about. I will speak about a couple of changes, and Emil will talk about a few more. So first of all, a rather small change that hasn't been merged yet, but there's a draft pull request up, and it's a matter of adding a checksum to the artifacts in the artifact creation. So I'll show you. That's actually a somewhat weird omission in the protocol, I think. And I think the more recent years focus on supply chain security means that I think had this been designed now, I think it would be very natural to include it. So what's being added is a new integrity protection member in the file information object array in artifact created message or event, which simply is the checksum of the particular file and also the algorithm used. Very simple, but this allows the party emitting the artifact creation to also state the checksum so that that can be verified afterwards and make sure that the artifact hasn't been tampered with or overwritten by mistake or whatever. Totally natural. Of course, to really make it secure, you probably want to sign the events as well. So the events announcing the checksum can't be tampered with, but that's a separate issue. And if we look at what this looks like in an example, let's see. Examples.
Is there a link there?
Yeah, there should be a link at the bottom of the documentation page, correct? That I probably haven't added that one. Okay. Anyway, I'll enlarge this one. Right, so here we have an artifact creation, and this array of file information objects is optional. We use it heavily because we have a lot of multi-file artifacts. And in this case, we have an empty file, and this is what's new, the integrity protection object, the SHA-256 algorithm, and the digest. Simple as that. So I hope we can merge this in a week or two. That should be very realistic. And that will be probably the last thing merged before we make the Arica edition. Any comments on this one? Questions?
It's very similar to the security
yes.
object that exists.
Yeah.
There's a similar construct within the security object, which is done for the event itself and not for the artifact. That's correct. Yeah.
Correct.
So, I mean, the idea of the syntax is taken from there.
Yes, I borrowed heavily from there. Yes. Both in the documentation and names of members and so on. Okay.
In this example, are you thinking of including the security, signing thing that we have today?
In this particular example file?
Yeah.
Not here, I think. That would be a separate thing. This is an example for connected to the artifact creation event itself. But that's maybe something we should talk about at a later point in time, namely the meta security. I mean, there's no reference implementation of it. There is no example that you can use to actually verify that your implementation of it is correct, which is a problem. But it's another problem.
How would you sign this message in a production environment? How do you ensure that we don't tamper with the digest?
There is the meta security member that includes.
Can you show us?
Yeah, of course. Let's see. I'll do it here. And wonder where the best documentation of this
There is
is.
a security page.
Yeah, there is, isn't
Yeah,
it?
I'm going to start the security. Oh. Yeah.
There we are.
That explains it quite well, I think. What parts it contains and so on.
Blah blah blah. Okay, this is more of a theoretical.
Yeah.
Maybe we can actually open the meta object. Maybe that's more.
It's best to actually open up.
Yes. We pick a random event and we search for. Yeah, here we are. So you would include the identity of the author who has signed the event, and you would use that to pick up the author's public key so that you can use it for verification. And then the integrity protection then contains the signature itself and the algorithm. And here is interesting. May include the public key for convenience. Okay, yeah. Interesting. But anyway, so what is actually done when you produce such a signature is you set the signature value to an empty string, and then you serialize the event as a canonical JSON, meaning you have the keys sorted in order and no white space in between tokens and so on. You run that through the whatever hash algorithm you've chosen with, well, it's HMAC since there's a key involved. You get the hash, you include it in the signature member, and then you're off to the races.
Okay.
And similarly, if you want to verify it, you would have to reset the signature, serialize it on canonical form, and do the verification. So the only implementation in existence, I think, is the one in the .NET SDK that Dual has put together. So I don't want to call it maybe a reference implementation, but it is a implementation. And we should include it in the SDKs as well, but we haven't yet. But I'd be happy to do it for the Go SDK.
And I made that run, for example, could create it itself without even having it in the SDK. I mean, the run client could.
Yeah, I mean, that will be a good reason for using RemRem.
Yeah.
But it's not entirely trivial. I mean, you need to have some kind of public key infrastructure to obtain the public keys and so on. So again, that's probably something we should talk about. And we talked about it on the bus over here this morning, and maybe we should produce a concrete proposal on sort of the best practices or how it should be done. Or maybe we should have a service for verifying events where you can add the identities and public keys of whoever parties are signing events in your organization, and you can very easily verify messages using that service. That could be one option. But of course, for producing signed messages, unless you use RemRem, you would have to have that functionality in the SDK or whatever local code you have that emits events.
If you go back to the message definition,
The example,
yeah,
or
example, yeah.
Let's see.
Where you started off.
Oh, the definition.
Yeah.
Yeah, we can. Let's see. Yeah. Hard to navigate with this enormous text. But
Yes.
here we are.
Is there any particular reason we have abbreviated algorithm to ALIC?
It's to align with how meta security does it.
Okay.
And I don't know if they do it for a particular reason or if that is to align it with something else. I don't know. We usually don't use abbreviations.
Yeah, exactly.
So I don't know why it's done in this case, but I did it to be consistent with meta security.
Okay, that's good enough.
I mean, since we're going integrity protection, file information, we're not that concerned about using.
No, so that's why I asked.
Yeah. It's
I agree. It's strange.
yeah. Okay. Moving on to another thing, which isn't technically a change in the protocol, but we have changed how the schemas are defined and how we work with them. So previously, this is what things looked like. All the schemas, they were stored in JSON form, sort of the raw schemas, one per version, and we had the documentation. We only kept the documentation for the latest version of each event type, and that was maintained in a separate markdown file. There was a number of problems with this. First of all, data duplication. Of course, there was duplication between event versions because they would usually be, of course, very similar, except for additions in later versions usually. But the common parts between all the event types were duplicated, mainly the meta member, but also the link objects. Massive duplication. I mean, the meta within the same edition, we make sure as maintainers that meta members will always be exactly the same. But there's nothing in the schemas that sort of proves that that's the case. It's more of a convention. And if you needed to update the meta member somehow, we currently have an open PR that does this. You have to bump the version of all the 23 event types and manually, well, it doesn't have to be manually, but you have to edit all those JSON files and make the same edit everywhere and make sure that you do it correctly. And that's rather painful. Secondly,
reviewing it is even more painful. I mean, if you create such a change, you might do it with some scripts, and you might feel confident that I've done it for all event types. That's fine. I'm confident. But when then someone else should review that, then that person also needs maybe to create a script, him or herself, or just rely on the contributor to actually have done that in a good way, because it's not really doable to manually review all these changes.
No.
I start crossing before you get to the middle of the event types.
Yeah, it's not a great situation at all. Another reason is that SDKs become very messy. So this example here on the right is taken straight from the Go SDK, where you might not know Go, but I think you can read this pretty well. So you have the data member has its own distinct type for activity canceled v3. That makes total sense. But the links and the meta, in this case, the meta for activity canceled v3 is exactly the same as for all other event types within that edition. Doesn't mean it's necessarily the same as in all v3 events, because different events, I mean, they are individually versioned, they have different life cycles, but there is no need to have really the same, to have different meta types that are unique to every single event. But since there's no way to figure out that different event types from the same edition actually have the same meta, there's nothing in the schemas that hint at this. I mean, sure, you could in code, you could compare the schema definitions and see if they are the same. Sure, we can somehow use a common type, but it gets very messy. So this is what was chosen for the Go SDK. And of course, the consequence of this is that you can't, if you want to write a function that somehow takes a meta object as input and somehow acts upon it, producing a signature or doing something, you can't really do that because they are all distinct types. You can work around that by using interfaces or similar, depending on what language you're using. But again, it's quite cumbersome. Another problem is that there's no way to convey what valid links there are for an event, because we are not encoding the valid links in the schema. That was not possible in the currently used version of the JSON schema. If we would upgrade the schemas to a later draft of the JSON schema spec, we would be able to do that. but we wouldn't be able to express everything. For example, the documentation states what event types you can link to. We can never express that with a JSON schema, so there's no way of validating that. And if you would, for example, an SDK want to validate this, you would have to hard code it into your code based on the documentation. So you'd have to look on all the 23 markdown files and hand parse it, and that's not a great situation. Of course, since the schemas and the documentation have been maintained manually, there can be inconsistencies between them. I discovered one or two such when I was making the change that I'm about to explain. Yeah, and smaller thing, but there's no really reasonable way to programmatically obtain the abbreviation of an event type, which you totally might need in, for example, an SDK. Or for that matter, the documentation of the members, if you want to include that in an SDK's Java doc or docstring or similar, you would have to parse the markdown file. So I think I've made my case here. So what we're doing now instead is that we have introduced YAML files that are basically, well, first of all, they are YAML instead of JSON. So we can include comments, and they are generally nicer to deal with, much fewer curly braces. But we've also extended them with extra keys containing metadata that isn't included in the JSON schemas, but that we can interpret using other tools. And from this common YAML specification, we can generate both the JSON schemas and the markdown files. So the end result is identical to what we have today. We haven't changed the structure of the protocol Git or the layout of the documentation or anything like that at this point. But since we are generating both the schemas and the documentation, we have much greater freedom of doing that. So after this change was made, the JSON schemas are actually bytes identical to what they used to be. There's no difference at all. The markdown files are visually identical, but contains small minor differences in terms of ordering of certain link types and white space and so on, but they are visually identical. But now we can actually change this by just changing a simple template file. The problem with the types that are duplicated, we solve this by using JSON references within the YAML files. So the YAML file here can, instead of containing the full sort of flat definition of the meta object, we instead reference a separate file for the meta property, where a human can version this subschema just like an event. So I think right now we are at 3.1.0 of the meta property, if I remember correctly. And an SDK generator would use this information to, instead of producing an activity created v3 meta, it would just have a meta v3, which is then shared among all the events of the same edition, which makes life a lot easier. So the benefit of this is we can change the documentation formats, we can make SDKs easier, and we still haven't changed the layout of the Git. So any existing tools that reference any of the files or read them somehow, old URLs are still correct. So there's no change in that regard. And one of the things this enables that we're going to do in a reasonably soon future is to publish documentation of the events on the github.io site that we looked at earlier. That would be a pretty simple thing to do now that we can generate documentation in any format we like. I think that was the last. Yes, any questions or comments?
Can you show an example of the YAML file?
Sure. We can actually look at this one, this pull request. So yeah, here's now we can include a copyright notice. We couldn't do that in schemas because you can't have comments in the schemas. So this is what it looks like. This is, I think, still too small. Let's see if we can. Is it okay? Okay.
It's from here.
Yeah, yeah. I was thinking of when we're filming this, but
No, that's not really.
but anyway, so most of what you see here is just straight from the JSON schema. It's the same thing. It's just in a YAML representation. However, we've added various underscore prefix keys that are special to this format. So we can grab this file and just strip all the keys with an underscore prefix, and we end up with a JSON schema, exactly as it used to be. But here we have the abbreviation. So if you want to know the abbreviation of a particular event, you can just grab that key right there. The description here ends up in the documentation. Here is the reference to the Eiffel meta property, as we call it. So going back to the example of the open pull request we have that adds one field to the meta member, we would still have to modify or create new event versions for all 23 events. That's still painful. But the change that would have to be done is simply a matter of bumping the version here. And we would create a new version of the Eiffel meta property schema. And then we're done. I mean, we wouldn't have to modify 23 of these files except for the version. So it's a lot easier. But reviewing is still painful.
The description is there as well per field.
Yes, exactly. Per field description is here also. We can also state with, oh yeah, there's some things at the bottom that we should talk about. We have the format where we, well, it's something we could fold it into the description, but we have it as a separate documentation key. But at the end of the file, there's also another top level field, underscore links, that encodes information about the valid links, cause, composition, and so on. And it's really just a structured way of expressing the information that we previously had in the documentation. And with this, we can actually write validators for events in, for example, SDKs. And at the end, we also have some other the version history of the event and so on. It is questionable whether this is, how we really should do it, but in the spirit of not changing things too much at the same time, I've just moved it from the documentation into this. And at the end here, the examples that also just end up at the end of the documentation. But as Emil mentioned earlier, it is painful to review these changes. And unfortunately, since we still have separate files for every event version, it's still painful to review. Instead of getting a brand new JSON schema file, you get a brand new YAML file. That isn't actually helpful. What we're planning on doing is writing a script that produces diffs from what you have done compared to what's currently on master, for example. And we would post this as a comment in the pull request. Or you could run it locally, and that way it would be quite easy to see what actually changed in the most recent schemas. We did talk about using not one separate file for every version, but instead actually using the version control system for this. It's totally doable, but it has a few drawbacks that we didn't want to do at this time anyway. But it's something we can revisit later if desired. But there is definitely there are benefits in having all the schemas available at a single time, instead of having to dig back to either the Git history to obtain an old schema, or maybe grab an artifact that like a tarball with all the schemas that we publish somewhere. That's also one way of doing it, but it's a little bit more involved, and we didn't want to take that step right now. Anything else?
And also, as people might have come to the new edition, they still might need the old schemas to validate again.
Yes, exactly. I mean, there are many cases where you need all the schemas, and just grabbing the Git from GitHub is a pretty convenient way of doing that.
But it would probably be enough with the JSON schemas, so you wouldn't need the YAML files.
No, that's true. That's true. Yep. But then you would, yeah. Good. I think that's all the news I had.
Yep.
And then you have, I think, 2 more things.
Yes.
Oh, let's see if this thing's up right. This way. Yeah, so there we go. So I want to talk about 2 other changes that has come in or is soon to come in. First one is a pretty small one. Add schema URL to the meta object. There was an issue created a year ago. Was a requirement from Ericsson from the beginning to be able to include a URL to the schema used when creating an event. So you see now a lot of schemas, and obviously those schemas should be, any event sent should be conformant with those schemas. But in Ericsson, we have the use case that we want to restrict those schemas even more. We want to have dedicated restricted schemas for certain types of events or certain events sent from certain systems and so on. So we are about to introduce our own schema registry internally, where we will then store all these schemas. So they will be, I mean, those schemas will be very similar to the JSON schemas we've seen just now, but with restricted, even more restricted strings or enums or fields in another way. So to be able to do that, we suggested some time ago then to include this schema URI parameter in the meta field, in the meta object. And this has now been implemented. It's about to be reviewed this week. So what it looks like in the documentation then, just showing here, is that we will have the meta schema URI field here. We will probably expand this explanation, the description a bit more, with maybe some more usage ideas on what this is actually needed for and so on. So this is just the simple change there. And thanks to the change that Magnus just showed, we don't need to do this explicitly in all the different event types, but instead it's just done now in the meta property file. So this is now based on the change that Magnus just showed, which means that a lot fewer files are manually updated, a lot fewer changes are manually made in the files at least. Yeah, that's what I want to say about that one. Any questions on the schema URI? Was it somehow clear why we need it, what it's used for? No. Yeah. Anyway, it's soon to be there now, so it will be in the Arica version most probably. Another issue that was created 2.5 years ago, when we started to think, I mean, Eiffel was initially created when we had, the idea was that any system should be completely event driven. Any activity started, step in a pipeline should be caused by some event, so that everything is event driven. Some years ago, at least in Ericsson, we started to use Argo workflows to drive our pipelines, which is then an explicit pipeline definition, which in its definition says, after this step, do this, do that, do this. And then the Argo workflow engine executes that description, that configuration. The same is for Jenkins pipeline. If we would use the Jenkins file there, and most of the, at least now commonly used CI frameworks, I would say, have such definitions. I mentioned before on these totally event-driven setups with Captain and Directive, for example. I'm not sure exactly how they define the full pipeline there, but regardless, this is quite common nowadays, that you have an explicitly configured pipeline definition somewhere.
So it doesn't then make real sense to say that this step was caused by the other step being finished, because it's actually an orchestrator on top of it that says, now you should do this. And the step itself doesn't really know that, well, I was started because that other step finished. No, I was started because my orchestrator told me to. But still you would like to say, be able to describe what was the previous step in the pipeline that I'm part of. So you want still to have links between the different activity events, but the cause link is probably not the correct link type to use there. And we have had quite lengthy discussions on this as well, not maybe as much documented as for the deployment events we talked about yesterday. But anyway, now we have come to a conclusion. So this one is actually merged. The pull request contains a change to, if you go through the documentation here, we have now something called activity linking here. In the syntax and usage section, which talks about how to link activities in different ways. And here we expand a bit on what it means to have an event-driven versus an orchestrated pipeline, as we call it. So it mentions fully event-driven pipeline or fully orchestrated pipeline, or something in between, because in most scenarios you probably have something in between. Some steps might be event-driven and some steps might be orchestrated. And it describes here what link types are involved in this. When you want to link activities, what link types are needed. If we just skip the precursor thing there for a while, we have cause and we have context and we have flow context. And then I just passed by this precursor thing. So we talked quite a long, what should we call this thing? Where we want to say that something happened before something else. And we've ended up with the term precursor, which is more or less like, yeah, this happened before that. This was the predecessor to that thing. So in a very simple example, two different activities, started, finished. This activity has a precursor link to the previous activity. So again, it was not caused by the previous activity being either triggered, started, nor finished, but it's still valuable to be able to show that this activity followed after this activity. In a visualization graph, for example, for your commit, it would be very valuable to be able to show that without trying to follow some cause links to some different events and then trying to understand what was the actual activity and so on. So, and if we have just a slightly more advanced example where you have parallel activities going on, we have 3 different parallel steps and then followed by one sequential step after those. All of those parallel steps are then precursors to this new, the 4th step. So they're all linked from the activity triggered event. And that's more or less what I wanted to explain there. Maybe I can also show this picture that we have in the, in the discussion, this one. Might be interesting to show for a more expanded example, maybe. So here we see on the top, well, there's a cause link to some source change probably happening, and then we have an activity triggered event, which is for if we would consider this a pipeline, complete pipeline execution. So this is the pipeline activity, which is started. The flow of time is not obvious here really, but don't regard the time there really. So activity started somewhere here. We have 2 different steps. Step 1A and step 1B, they are done in parallel. And then after that follows a step 2. So there are two parallel steps, one step, and then another step there. So step 4, but it should be step 3, but anyway. So this step was not caused by any of these being finished, but rather by the orchestrator telling this step to start. But then we include the precursor link to the activity trigger for the step 1 and to the step 2 there. Sorry, 1B. And then the next step has a precursor to the step 2. And then internally, if this would have sub-steps in it, for example, sub-activities, task 2.1, task 2.2, there will be precursors between these tasks, so we can see in which order these are done. Obviously, we have the context link today. The dotted lines here are context links. So they would say what top activity are all these steps part of. But those links won't help you with saying when did they happen and in what order and if are they parallel or not. So that's where the precursor comes in to play to be able to line it up in a graph when you follow your commit or something like that. Yeah, what else? There's an artifact being created in one of the steps, and it has a context to that sub-step where it happened. But still no cause links at all in this picture. It isn't really needed. Except for the top cause. So this is a totally orchestrated pipeline view example. Is this understandable? Is it useful? Is it? Yeah,
I think one of the things we talked about was that consistently using precursor would make it easier for visualizers to not have to traverse the graph in different ways, but have more consistently support the visualization.
Yeah.
So I mean, you could use the meta.time to order activities, to set them into order, but it requires more special treatment of the events.
Yeah. And this with having two precursors from one step to previous parallel steps, or as I showed another picture with the parallel things there. I don't think we allow multiple cause events, or if we do, it's a bit strange to think that we have multiple causes of one thing happening. It's still
you could wait for multiple artifacts.
Yeah, but then it's like a coordinator thing that actually waits for those and then triggers it. It's not really the activity itself that is caused by all of those individually. It's caused by the combination of them, which is then shown. Yeah. So yeah. Anyway, I think this makes it more clear and more easy to follow as a consumer of the events. You could combine cause and precursor event links as well. And as Magnus said, it makes it easy if everyone used precursor links to enable for the consumers to show this visually, regardless of if it's event-driven or orchestrated or a combination of it. Then the consumer doesn't need to care, doesn't need to know if it's event-driven or not. Today, it doesn't need to know that. More questions? That's it then. So all these 4 things come into the Arica edition.